Something that comes up on your exam every year is margin of error and hypothesis test. Or something like in this particular year, we didn't have that word used. It was only talking about 5 level of significance test. So that's something to just watch out for. However, it was unusual for them to just use that expression without hypothesis test. However, once you see margin of error mentioned, that basically what follows. So let's see. A random sample of 815 cars were picked from new cars in 2024. Show that this sample, the margin of error for a population proportion is 3.5% correct to 1 decimal place. So margin of error, how do we calculate that? 1 divided by a square root of n, which n means number in the sample. Now the difficulty with that is that we don't have that in our tables. We have to remember that that's how we calculate margin of error. So in this case, number of sample is 815. We put that in the calculator, we get a decimal, and then decimal change to percentage, move 2 places, indeed is 3.5%. Okay. 106 of the 815 new cars bought in 2024 were electrical cars. Work out percentage of the new cars in the sample that were electrical cars. Give your answer correct to the nearest percent. When we are talking percentage, we are thinking about fraction. Remember, fraction is the whole cake at the bottom and my slice on the top. In this case, the whole cake is what? All cars. And the slice out of all these cars that I am looking for are electrical. So in this case, we have 106 divided by 815. Again, we put that in the calculator, we get a decimal. Oh, that's supposed to be 0. Don't know what happened there. So 0.061. Change that to a decimal, we either multiply by 100 or we move decimal 2 places. So we have 13%. Now, next part. In 2023, 19.2 of all new cars bought were electrical. A reporter claimed that the proportion of new electrical cars being bought in 2024 was different to 2023. Use your answer to part C1 and 2 to test the claim that the percentage of new electrical cars being bought in 24 is different from that in 23 at the 5% level of significance. And that's what I was talking about. Normally, they will mention here that tested, use hypothesis test. They didn't in this particular year. So that was that difficulty. However, the previous 2 parts were kind of a given because once we talk about margin of error, then the next part is population proportion, then the next thing is hypothesis test. We have to show calculation, conclusion, and give a reason for our conclusion. So what are the calculation? What is happening here? So our calculation. Now, don't forget that what happened is that first we have a behavior or we observe a whole population. So this is the idea. This is what happened. That is the whole population. That was year 23. And in that year 23, 19.2% were all electrical. Okay? Then look at that. In the beginning, we have, in 2024, we have a sample mention. We didn't check all the cars, but we took a sample of 815 cars. So the idea here is, with this test, is that nothing have changed because that test is based on a null hypothesis and alternative hypothesis. Now, where will that go? In our question, this will be the reason for our answer. Normally, this is actually our starting point because we should always state or identify what is the null hypothesis, what is the alternative. Null hypothesis will say nothing changed. In this case, that means 19.2% of new cars are electrical. So that's what we are saying. Nothing changed. That proportion didn't change. The alternative hypothesis will just say it's not 19.2% of new cars are electrical. So it's just the opposite of the alternative. We are not stating a different number, nothing. We're just saying not what was in that first part. So that's what we're going to have in our reason for the conclusion, but that's really where we start. And then we go for the calculation. So again, the difficulty here is to remember this formula. So that P means population proportion. And that is basically that our fraction from the second part. We are saying that out of 815 cars, 106 cars were electrical. Then we are taking plus minus because we're going to do both calculations. So we're going to say first, okay, maybe let's write it so that make it clear, minus, and then that's what we got in our first part, that is margin of error, so that is one value here, and then the same thing, but the second version is with plus, so that we get the two values here. And then when we put that in our calculator, we can write it as a decimal or percentage. So here we're going to have 9.5%, and here going to have 16.5%. Now, what are we testing? We are testing population because these are results from the sample. Out of 815 cars, 106. That was the sample test. But we are testing the whole population of 19.2. So where is 19.2? Well, it's here somewhere outside those two numbers, isn't it? Because these numbers goes from 9 to 16. So 19.2 actually is going to be outside. When our value is outside, therefore, we reject that null hypothesis. And that's the part of either our calculation or part of our reason for conclusion. We will say as 19.2% is outside of 95%, because that part is called 95% confidence interval, of 95% confidence interval, we reject HO means null hypothesis. Okay? So actually what we are saying, it is true. It is not 19.2% of the new cars are electrical. And that is going to be conclusion. So in the place where you have their conclusion, we're going to write that, therefore, not 19.2% of new cars are electrical. Now, if that 19 was inside, if we have a different value, if that number we are testing of population was inside these two numbers, then we will say that we don't reject the null hypothesis, that null hypothesis is true. And in our conclusion, we will say, therefore, 19.2% of new cars are electrical. So that's really it. It's a little bit more of writing, not that much of calculation. Again, can't stress it enough, the difficulty, that formula, not in our table, so we have to remember that's the formula for 95% confidence interval, and that first one here, that's the formula for margin of error.